Okay, so for those who haven't been following the AOSP master a lot, this may come as a surprise. There's some big changes in the toolchain ahead. AOSP is moving towards clang-based toolchains and dropping GCC. Current AOSP master, including what was just released as the end preview, is already built almost completely with Clang 3.8. Only the kernels and some hell layers for older devices remain on GCC at the moment. Why are they doing that? The primary reason I've heard from them is that they want to use the APIs of the toolchain for GUI tools like Android Studio. With GCC, essentially the only way you can get input that would be useful for an IDE is to run the command and parse its output on the command line, whereas Clang allows you to tie directly into the APIs of the compiler to run a particular step and see what the output is in a much more direct way. Then there's improved compile times. Generated code quality is similar to GCC, sometimes better, sometimes worse. Clang is more easily extensible, already has some support for GPUs and DSPs, like the Hexagon DSP that is found in most current Qualcomm SoCs. So it's already present but unused in quite a few Nexus devices. And lastly, there's licensing. Most of us may not agree with that part, but the Google guys don't like the GPL too much and prefer BSD licensed compilers. And one advantage this has, even for people who actually like the GPL, is that it allows us to work with certain other mobile phone companies that run a different operating system, so we can benefit from the changes they make to the compiler as well. What are we doing in Linaro to help the effort? Quite a bit. All the initial patches to make it build with Clang were sent by Linaro. Then right now we are fixing up assembly code, so we don't have to use the -no integrated AS with Clang, at least in the ARMv7 and ARMv8 worlds. We don't care that much about x86 and MIPS. So what -no integrated AS does is, by default, Clang has its own built-in assembler as well. And with -no integrated AS, that is turned off and the regular GNU assembler from binutils is used instead. Right now, that GNU assembler is still needed in a couple of places because code uses syntax from before the times when unified ARM assembly syntax came out. Clang only supports the current standards. And there's one instruction, or pseudo-instruction rather, ADLR, which currently makes some problems. But overall, we have patches for getting the entire tree to compile without having to use no integrated AS. And, so far, there's only one known bug introduced by those patches. Yeah, the next thing we're doing is testing newer Clang builds, so making sure everything can still build with newer upstream versions, and preferably without modifying the upstream compiler releases too much. And just like earlier on, we submitted patches to make it build with Clang. We will continue supporting GCC at least for a while, and make sure newer GCC versions keep working well with AOSP, even if upstream is completely moving towards Clang. It's always good to have more than one option. So other changes related to toolchains in AOSP are build system changes. Up to AOSP M, only OpenJDK 7 was supported. Nowadays, OpenJDK 8 is required. And the Java tool from OpenJDK is being replaced with Jack, which is a Java compiler written in Java that has a client-server architecture. So one of the advantages they are seeing is that a lot of time just starting up and shutting down the VM every time a new file is being compiled can be avoided. Ninja is replacing GNU-Make. I'm not sure how many of you have seen Ninja. Essentially, its maintainers describe it as Ninja is to make what assembly is to C, so it's a lower level thing. And nobody would want to write Ninja files manually. So right now, there's a tool called Kati that converts the existing make files to Ninja files, and then it runs Ninja on those. And in the future, it looks like Android MK files will be replaced with JSON-like files for a new tool called Zoom. That's a make file generator, or rather a Ninja file generator, that will replace the Android MK files, possibly even in time for N, probably for O. Maybe never. It's a tool that is in development and might just still get canned, so there's no complete confirmation of any timeline for this yet. Sir? So the question was, why not use CMake? And I don't know. Personally, if it was my decision, I would probably have gone with CMake because that essentially gives us all the flexibility we'd need as well, and it also supports generating Ninja files. But it might just be some version of not invented here syndrome. Or maybe they also want the extensibility in Go modules that I'll talk about in a bit. So the files controlling the Zoom are kind of similar to what's currently in Android MK files in a more JSON-like syntax. Let's look at the one that they're currently using to build libpng. So it sets parameters, compiler flags, pretty much like we used to see it in Android MK files. Then puts up a list of source files, calls the CC library module, which means build a library that is written in C or C++. And then lists parameters, name of the library, whether or not it can be built on the, for the host as well, or if it's just for the device. Then it lists the source files relevant to that. It tells it it can build the whole thing with Clang, doesn't need to fall back to GCC for anything. Needs to pass those additional compiler flags. Shouldn't be using the sanitizer. It should add -i for the current directory. Then we have the target definitions. So when we're building the host version of libpng, which is used at build time for generating some icons and the likes, we need to link statically to libz. And when we're building for Android, we link dynamically to libz, and we add the additional cflag -f trap v, which essentially traps integer overflows instead of exposing us to a security vulnerability there. Then there's some architecture-specific things. When we're building for ARM or ARM64, we use those extra files, which essentially are assembly files with neon instructions, and we pass some extra cflags. So those would contain stuff like -m CPU equals Cortex A72 or the likes, whatever we are targeting. Then here you can see it also supports comments that look pretty much like in C++. And here CCBinary is invoked. That's another module that just builds a binary. And again, it takes a couple of parameters, Clang, whether or not it should be using Clang. So then source files, name of the binary, shared libraries to link to. You could also say static libs, and then it would link statically instead. And tags is similar to the tags thing currently in Android MK, decides in what types of build this file will be included. So Zoom is written in Go, and functionality not covered by the functions like CCBinary and CC library we've seen in this example. can be added by writing Go modules that provide the functionality. So this should, for example, make it easier to integrate some third-party tools that use their own build system. You could write a Go module that invokes autoconf or CMake or whatever, and then goes on to build whatever is in the output of those tools. Even though the build system seems to be moving towards including Go components, there are currently no signs of any official support for Android applications written in Go. But that may actually be worth fixing, especially if we want to take the next step and make AOSP self-hosting. There's some work on this going on already. So in the first step, we are trying to get AOSP to build on ARC64 Linux boxes, so we eliminate the need for x86 build machines. This is already in progress and kind of working. We have the compilers working. There's currently just a couple of missing extra tools. And in the second step, we would like to also make it possible to run on ARC64 Android. So some of those more advanced devices could be a lot more useful. With the Pixel C essentially looking like a notebook, it kind of makes sense to want to develop applications right on the device and also to just build an OS update on the device itself. Yeah, there's some other languages outside of Go that could be useful, and in the first step, Tom wants to talk about Swift.
Okay, so before I get into this, I just want to make this clear. We're talking about things that are highly experimental. This is kind of neat, kind of interesting, things that we're sort of watching, and so we would just kind of want to impart some information as far as what's going on. So if you go back to the very beginning of when Apple released their mobile devices, they were basically telling application developers they had to use Objective-C, which of course is its own little variant that's been around since the 80s. And it became kind of more increasingly obvious to Apple that application developers were kind of running into common problems and the language is kind of being a little bit of a pain in the butt to use. So they went off and they invented a whole new language, and that language is called Swift. They released it a couple years ago. Again, it was just something for mobile use and mobile development, kind of in its own ecosystem, closed, yada, yada, lots of evil things about it that, of course, as open source developers, we don't like. Well, for reasons that Apple has, not quite fully communicated, this fall, so just a few months ago, literally, Apple released Swift into the open community. And that means the source code is out there. That means there is, all sorts of mailing lists that are out there. And, suddenly they're trying to develop more of an open standard. And, okay, that's kind of interesting. Well, let's be skeptical for a moment and start applying standard open source best practices and sort of use that as evaluation of should this or should not this project even be interesting. I mean, certainly it's strategic to Apple and their app developers because they need to use Swift for developing their own apps. But is this something we should be interested in as a language, and could this potentially run on Android? Okay. Well, one of the things which is most notable if you go take a tour of swift.org is that they make it very clear that anybody who is sane can go and post modifications to the actual design of the language, and as long as you're not really, really out there, they're going to give this a reasonable reasonable hearing as a change, something that they should go off and do and change the language. Okay, that's interesting. That's involving the community in designs and taking the community serious. And we now have a body of work several months in that's exactly what Apple said they were going to do, and that's exactly what's happening. Okay, that's interesting. What about support for other platforms? I mean, okay, Apple has their own iOS stuff, but what about x86 Linux? What about ARM Linux? What about running on Android? down here on my laptop, I started porting Swift to ARM Linux. It wasn't that difficult. Clearly, they had started to give some thought as far as running Swift on other environments, and as it turned out, when they open sourced Swift, it was already running on x86 Linux. So this was something that was a proof point of when they went out the door. So going forward, it's interesting because getting it to run on ARM Linux, it was more about dealing with tuples and just kind of simple kinds of things that those people who are not very familiar about working with the Linux environments and some of the tools and things that you need to look for when you're building something in the same fashion, that's what was tripping them up. So clearly they were turning to the community to get help in this area to get the language in other environments. And in the case of bringing this technology to Android, it's sort of the same problem. It's not that the code that's there is unreasonable. It's not. It's C++. It's pretty straightforward. It builds with Clang already. It's more about just going through the steps to get it done. And it's not as if Swift has a lot of dependencies to actually do the build. Okay, so if we do this and we get it done, and I think it's going to happen because they're not just individuals like me who are contributing packages. There's actually a number of other people who are kind of getting involved with it. What do you really get out of this? Well, on an experimental basis, basically what you end up with is you can now run Swift code that might be on an Apple Watch or an iOS or running on Android, unchanged. That's one level of cool. However, the one issue is what about UIs? Well, in what has been open sourced by Apple, it does not include any of the higher level software development kits that an app developer needs. So that's where the usability kind of dies and the usefulness of this dies. Command line stuff, great. They've got the foundation kit there. They got all the things that you need. But as far as, really could you build an iOS app with a beautiful UI and then have that same beautiful UI run on Android, source unchanged? No, sorry, that's not in the cards yet. That's going to take a lot of work if somebody's going to step up and do that. Now, another thing that I think is very important here, because this is an open source project and we must apply this test as open source developers to Apple, is how open is this? How dedicated is Apple to an open source ideal in Swift? Well, as it turns out, they're a little bit more advanced than other companies who have open sourced their technology. Apple has specifically said within the project documentation, they will allow maintainers, they will delegate, commit authority to other people who aren't even Apple employees. That is perfectly well within the cards. Those people just need to prove themselves, they need to be dedicated to the project, and they need to be active and be working in the best interest of the language. That's an interesting breath of fresh air. That doesn't necessarily say that this is a panacea, but it makes it at least interesting. So as I kind of mentioned, that really the big thing to make this useful after we're just getting it building and running command line Swift applications, it really gets into the UI and the higher level functionality that app developers would expect to be there. I think Apple does want to kind of put forth the idea that Swift will be used in server environments, so that's maybe a stay tuned kind of thing. But again, with a mobile focus, which is kind of where I come from, that's not necessarily perfectly interesting. Yeah, well, it's, it takes away from the need for a UI if you're just going to be in a server environment. Yeah.
There's a lot of IDEs out there that you can write once and then compile to Android, iOS, and Windows, and whatever. And what they do is they use different UI calls for different platforms. But if the language is Swift or C++ or whatever, it makes no difference. The only thing you need to do is to make sure that Swift can connect well with the Android UI. Instead of porting the Swift UI or iOS UI into Android, there will be a much quicker path to get the application, but then the look and feel will be Android rather than and then, you know, the application will probably not behave in the same way and not expected, but the language doesn't change the fact that you can actually run on Android with native Android look.
That's a very good observation, Renato. You know, that's the theory. Now, the reality is as far as how Android works with intents and just the way it presents, you know, UIs is substantially different than the way that iOS does it. They are completely different models. So, you know, how you would impedance match that, make that work, somebody's got a lot of effort to do that. And, you know, that's not something that, you know, we're looking to do. In our case, we're just evaluating this, seeing, you know, just what's going on in this community and just how sane is this technology so far. Okay, next one was kind of Objective-C and C++. I don't know, Vero, you want to kind of take it from here? Yeah. Okay.
So while looking at other languages, and after Swift, obviously the next thing that comes to mind when talking about porting applications from that other OS is Objective-C and Objective-C++. And turns out this already works. We can go into the NDK build scripts and just change one line of code which says enable languages equals C, C++ to enable languages equals C, C++, Objective-C. And we have essentially working Objective-C support on Android, but it has the same problem as Swift. At the moment, the UI libraries are not ported. So again, you can only get text mode applications and you can create library code. Another language that could be useful in the context of Android development is Rust. I'm not sure how many people have heard of that one. It's released by the Mozilla Foundation. It is in many ways similar to Swift. Their syntax is really similar. And also, their backend is, in both cases, based on Clang. So pretty much the entire backend stuff is there, and AOSP support should be easy to get. And of course, our favorite languages, C and C++, are always useful, and they're already supported, but even here there's some room for improvements. We could, for example, use some libraries doing JNI wrapping for talking to AOSP components written in Java. Pretty much everything that is specific to the system right now, like notifications or sending intents, is pretty hard to do from any language other than Java, and that could use some improvement. And also, components that already exist, like Qt for Android, especially the Qt creator part, may need some changes to work well after the transition to Clang, because there's a couple of hard codes on GCC-specific behavior in there. That's pretty much all we had. Do we have any questions or other ideas?
Will Linaro do some optimization on clang?
Sorry, could you?
Will Linaro do some optimization on clang or just GCC?
I think this is probably best answered by Renato.
Yeah, we do. A lot of optimizations in middle end and back end, but it's mostly fixes for now, but we do optimizations, and we just, like, if you have anything in mind that you want, you know, if you have a problem that you identified of lower performance in Clang than GCC, then feel free to create a bug and we'll look into it. This is something we can do and we do.
Okay, anything else?
So the first one was about building the Clang 3.8.
Right.
Is that with some additional patches, or is it standard 3.8 Clang?
So at the moment, it is Clang 3.8, actually a snapshot from SVN from a couple of weeks before 3.8 was released, with 2 or 3 patches on top of it.
Right.
And one thing we will be doing is try to get those patches upstream so we can just use the upstream compiler.
Okay. Okay. The other one was, you mentioned the native toolchain, right? Is that Clang or GCC, the native build?
We already have GCC working kind of natively, and we are currently working on also getting Clang working natively. And then afterwards, there's a couple of other components that we haven't even started working on, which would essentially include all the tools needed only to build AOSP, like the entire open JDK toolset that's required to build jar files and everything that's part of AOSP.
Okay.
Working in the device.
Right. So essentially, if anyone couldn't hear it, the comment was we need to have Clang running natively, especially with Swift and the likes coming up, because there's no way to build those without having Clang on the device. Obviously, there is always the solution of just cross-building on your desktop machine, but we are talking about making those higher-end devices a bit more useful than they currently are.
Yeah. End users don't like cross-compiling, and I understand why.
Right.
So what's the state of building Android on ARM64?
Essentially, it works, no problems,
And
but
is there anything
we are
missing?
still missing a couple of tools to make the final process of linking the images together and stuff work.
So are you planning on upstreaming this to AOSP?
Yes, but obviously that's one of the things that may take forever because they don't really care all that much, and I expect that this patch set will be sitting in the queue for quite a while without anyone going in and just committing it.
Probably not anymore, like the addition of the ARM servers. Probably everybody's interested in this.
Okay, anything else? Doesn't look like it, so thank you for attending.